I bought a machine at auction that doesn't exist. Hear me out. This is supposedly an H.C. Evans pushover machine. However, there is nothing for that online. I bought this at auction, I threw a $30 bid at it because nobody else was bidding on it, and won it because, well, it is pretty destroyed. It was sold as a barn find, and I 100% believe that. This side's a little bit worse. I actually discovered how this game would work. So, you put your coin in here, and then you use this lever to move this side to side, and then you'd hit the button to get this to swing up and scoop up the prize. And your goal would be to make the prize go out that. And then when it did, you could get it out right here. But looking online, there is no record of this machine ever existing. They've made a bunch of games, this company, but this game isn't listed anywhere. So this game doesn't exist, according to, well, anything that's on the internet. I probably am the only one that owns one, and I'm sure I'm the only one posting on the internet about it. The unknown machine has been ID'd, it is an Evans, and it did exist. That is amazing. I'm replying this person because they're the ones that sent me the files first. They even dug up an Instagram account I haven't used in 2 years to send them to me. And they found two different ones with this one here. They 100% match this machine. This machine has those same white bars on the front, has the same clown on the side. It is definitely this machine. Unfortunately, there is no date that I can find that dates this. However, I did a little bit of research and I have a good estimate of when this was made. See, if we look at this address right here, this was their last factory location before they closed in 1955, I believe. So I'm assuming that is the address they switched to. They had a total of like 3 different locations. I'm assuming they switched to that address when they bought the one jukebox manufacturing company in 1948. So I'm assuming this machine is late 40s, early 50s. That is my best guess. Now, unfortunately, this side will probably have to be replaced. There is no artwork left of it. It's pretty puffed up. It's pretty weak. So this side will probably have to be replaced. We'll cut that out and we'll just make a new piece of plywood that we can put on there. And so with the top. The top definitely took the brunt of the moisture. So the top and this side will have to be replaced, but I think everything else can be saved. And I even have the missing trim piece for right here, so we'll definitely be able to reuse that as well. We'll also probably have to replace that board. I didn't see how bad that was. That'll probably have to be replaced too. But everything else should be fully refinishable. This whole frame here, completely refinishable. I'll just have to repair it right here, refinish this. That'll look perfect. I don't think I'll have to do anything with replacing wood there. This front is totally savable. We'll have to do a little bit of repair right here, but the rest of this is in great condition. We'll be able to save that. And down here is obviously in amazing condition. Absolutely nothing will have to be done to this besides repainting it. Obviously this side is definitely completely savable. It is beautiful. So basically, there'd be a whole bunch of prizes in here. And you'd put your coin in the non-existent coin door, and you'd use this lever to move this thing. However, how would this move? Well, there's supposed to be strings attached to each side of it that would roll on these little pulleys, one on each side. And how that would work is you'd put in your coin, and it would make it so that was then activated until you either twisted the machine, which would trigger this tilt switch, or, won a prize. Basically, whenever you twist this lever, it presses one of these 2 buttons, which activates one of these 2 motors, which would spin this barrel in one of 2 directions. I don't know why I keep calling this a wire. This is actually just a piece of string. But it would run off of random pulleys, off of here, up to those pulleys that you saw up in front. So we would move this side to side to line it up with whatever prize you wanted to win. Then whenever you'd press the button on the front, it would activate this motor. This motor would both lift this lever up, which opened up the prize door for the prize to fall through, and it would pull down that lever. And that lever, which would activate this gear right here, when not gummed up, it would be pulled down, and it would rotate this and tilt this thing up to try and dump the prize through this coin door that would be open. Not coin door, prize door. Then, assuming you won a prize, that would fall down to the door, it would land in here, slide down, right to that door that you can open up and retrieve your prize from. Really cool. Rewiring this cabinet's gonna be fun. I found what's left of a solenoid here in the bottom. It's seen much better days. There are literal vines growing on this power cord. That is insane. Yeah, I don't think I'm gonna be plugging this one in. Now, I'm leaning towards fully restoring this thing, and here's why. See, there's no other examples of this. If there was a million of these, like any other arcade cabinet, I wouldn't want to restore it. I'd want to keep the patina because it looks cool the way it is. But, unlike a Miss Pac-Man, everyone has one of these. There's a reason I didn't fully restore this. It makes it look cool. It makes it unique. If you fully restore it, it's not unique anymore. Everyone has one of those. But, this is unique. Nobody has one. There are no examples of it left. So, if I don't fully restore it, there's no examples of it the way it should look. So I think I should fully restore it just to, have the only one of these in existence and have it look like it did when it came off the factory line. It looks like this blue is less faded than this blue, so it was probably covered, and it looks like it was probably covered in white. So I'm assuming this was entirely white, and then these strips were actually a red or an orange. I'm thinking red, but I'm colorblind, so I'll have to check. But I'm not sure. Is that how you think it was? Do you think this was solid white and then red lines through it? Or how else would it have been? I can't really figure it out. See, over here, it looks like it was solid white with red lines. That's what I'm guessing. Somebody actually sent me a taller version of this that has the date of 1951 at the top. And these appear to be the only photos of it that exist. And, that's not that great. Now, if you Google it, you might come across this photo, this photo, this photo, and this photo. And that's because, it's the one I bought. So, this is not a second one. This is the one. And let's start restoring it. First off, we're going to start by restoring this glass frame. However, 2 seconds before I started recording, I realized I can't actually glue all 4 edges together, or there's no way to put the glass in. Glad I realized that before I glued it. But we can still glue 3 of them together because this isn't attached in any of the corners anymore. So we need to fix that. And to get this off, we would normally use the key that does not exist. That's a really weird key. I'm not even sure what kind of key that is. That means we're going to have to go from, well, luckily, the inside. There's no glass, so that should be pretty easy. Also, this is like the 5th wasp nest I found in this thing, so that's fun. So my dumbass just realized that, well, this inner board's also going to need replaced, but more importantly, there's stars on everything. How did I not realize that? Like, genuinely. How am I just now noticing that there's stars on literally everything? First off, we need to fix this crack. It's bowed upwards, outwards, all directions. So we're going to clamp it in the vise, use that clamp, and we're going to fill it with wood glue just to glue it together. And I'll take anything I do as a guide. I'm not a woodworker, never claimed to be one, never will claim to be one. I'm just doing what I think will work. So that didn't fit in the vise with all the clamps I ended up needing. So we ended up with this, but that should be dry hopefully by tomorrow. But let's move on to these. See, while none of these seem soft, I don't want to run into a soft spot while sanding or something like that, and I already spent $40 on wood hardener, so we're going to wood harden all these. This is the stuff I've used for many years now on anything from water-damaged arcade cabinets to water-damaged arcade cabinets. Pro tip, this stuff melts through styrofoam cups, as I learned when I started out. It also melts through plastic cups, as I learned when I started out. So I just used the bottom half of a soda can. I think I'm actually going to lightly sand the surface of these first, just to get any hard junk off the front, so the wood hardener can seep down in. Beautiful. Let that soak in there. We'll probably say, oh, that's going to make it harder to sand. And that's the point. The last thing I want is it to keep, flaking out while I'm trying to sand it, so I keep having to go deeper and deeper. So the wood hardener is to help hold it together. That's much better. It's no longer weirdly bowed in random directions. Bit of towel got glued on, but that'll get knocked off as soon as I start sanding, so let's start sanding. Okay, I have absolutely drowned this board in wood hardener because this is the board that was closest to the side, well, it was on the side that had the most moisture and water damage. So if any of them were going to be soft, this was what's going to be it. So I made sure I drowned it in wood hardener. Now, let's fix this. Obviously, we can't have that giant chip there. I'll worry about the inside once I glue the other board on, but this outside we can work on. Okay, all of the wood has been wood puttied. And second coat's on. Let's wait till that dries, and then it should hopefully be the final coat. We can sand it, and finally glue this frame together. Let's fix that. This is not going to come off easily. Alright, it was most definitely glued on. Also, there's apparently a fluorescent light behind here, so that's cool. But more wasp nests, more spiderweb nests, awesome. Yeah, we're missing quite a bit of the sign, including the interior of the V and all of this. But let's just glue what we have together. And I'm using super glue instead of wood glue because, well, can you really call this paperboard wood? So let's do it. Okay, it's been 24 hours and we now have 2 pushover sign halves. So now let's attach the 2 halves together. Then we'll only be missing all of that and the middle of the V. And that we're gonna have to custom make. Okay, now let's wait for that to dry. The V should be really easy. Let's do that now. First, we need some of this kind of wood. Luckily, I think I might be able to find something. Boom, I found some of the exact same type of wood. It's the exact same thickness and everything. I'm pretty sure this might have been a white board at one point, but it's now going to be used for this. So, that's perfect. Let's get to tracing and cutting. I'm pretty sure this won't work. But who really knows? Okay, I traced over with Sharpie so I can actually see it. And we can obviously tell here to here is where it came down to actually support the middle. So we can just take our line and just trace a straight line down so we can get that lined up already. And just like that, we now have a V. Beautiful. Probably should have made it a little bit wider. Maybe I will. I don't know. But overall, I think that looks pretty good, especially once, it's all painted to match. Honestly, I shouldn't be doing this. I should have bought just wood and just cut out a new one. But we're not doing that. So let's cut this out. Not really. I traced it so I can figure out what the hell to cut out. I need to turn this into a P, a U, and an S somehow. This is going to be real fun. Okay, I ended up with this somehow. Let's cut it out and see if it even fits remotely. That's looking pretty sick. Unfortunately, now I have to actually cut out all the letters I drew. but let's hope it looks good once I do that. That's actually looking sick. I just need to build the little piece that's supposed to be here, and then I just need to measure these and cut those into it. That's looking awesome. Turned out way better than I thought it would. That part's done. Okay, edge to edge, they're 23 millimeters apart. Got it. So from right here, starts right there. That'll make it easy. Okay, let's cut them out. Would you look at that? That is sick. Now, obviously, you can tell there's some gaps, you know, between the stuff. But that's going to get filled with, obviously, super glue, and obviously then probably some wood putty just to smooth it all out, to make it blend perfectly under the paint, so once it's painted, you can't see a thing. But that is sick. I cannot believe how well that turned out. And, yeah, that V isn't right. Let's fix that. It's supposed to look like those, 2 pixels. So we need to figure out how to make it look like those 2 damn pixels. Also, somebody mentioned that my S was wrong, but honestly, that S looks damn near identical to mine. Like, I mean, okay, maybe this should have been a little bit fatter at the back, and this probably should have been a little bit more rounded. But other than that, that looks pretty damn identical. My U is wrong, but I don't care about that. Now, what I think this needs is, well, one, these sidebars don't match. As you can see, this one doesn't have those sidebars. Plus, this neck here is a whole lot thinner, which is probably why it broke off. And this V itself is a little bit lower down. So I'm going to redesign this exact same thing, just without those sidebars, this being a little bit thinner and a little bit longer, so it comes down just a little bit further. And I think that'll make this look perfect. Looking at these 2 pixels, it kind of looks like the inner triangle is even with a line right across here. So let's try and figure out how that would look. I think it'll work. Let's do that. Okay, yeah, that does look a little bit more correct. But before we let this set and glue, let's fix the U. I can't live with that. Let's make it look right. That looks much better. I also went ahead, rounded off some stuff, squared off some stuff. I made the S a little bit more curved, a little bit fatter in the back, so the S is now correct. Don't at me about that shit. Just gotta glue it, and it should be done. Okay, I kept going back over the V. I did it again. I think that one looks better. So we're gonna go with that one. Okay, it's been glued and wood puttied. We'll let that dry, and then we'll start sanding. Beautiful. Look at that. Now let's sand off this wood putty and put a new coat on. That's looking pretty sick. Now let's put on the second coat and then let it dry. Now I probably will put some reinforcements on the back just because, well, it broke once and it's probably more fragile now. So we'll probably do that. Shout out to Corey for sending me this in an email. And zooming in way down there, Evan's pushover. Let's zoom in a little bit better. Evan's pushover, $3.95. And right here is a copy of the email showing you exactly where this came from. October 6, 1951, the billboards, coin machines, page 89. And bottom of the page, yada yada, $3.95. And just to verify that, here is the Billboard magazine from October 6, 1951. And right here on page 89 is that same article. And zoom in way in, Evan's pushover, $3.95. And because I know everyone was curious, including me, $3.95 in 1951 was $4,500, which sounds about right. Time to start restoring the actual cabinet. And to do that first, we're going to start by restoring these metal pieces. Took off this piece of metal, and that's going to help a lot, because that is unfaded blue paint that we can use to paint match this thing. Also, it helps because now I know that this inside was white, which I figured it was because of that door, but even more importantly, the stars are gold. So we know exactly what color to paint those. Looking at this very closely, you can see red. What's left of red on here. So I'm assuming this also had red and white stripes on it, just like, well, all the other artwork. So that's super useful. We now know what color to paint this. Alright, I'm going to remove all of the screws that are in this, just so I can, sandblast them and make them shiny. Okay, it's been stripped down quite a bit. This screw is actually holding in, well, everything. This whole thing is removable. The hell? Well, that's awesome. Not sure how useful it is, but it'll make replacing that board a lot easier. Okay, that's pretty cool. It also lets me answer the question of if these are bent or just cut, and looking at the grain of the wood, they're cut, not bent. Also, I'll admit, while pulling this thing out, sticking my hand into a bunch of fuzzies to carry it out was not very comfortable. You know what? This is actually going to make working on this way easier. I can actually get to all of these electronics, which is good, because I need to make a wiring diagram for this, because I need to figure out what would plug in there. Obviously, the CoinMax stuff would, but that's more than just a simple coin switch. And just going over this briefly, there's a lot of stuff that's going to be missing. There's a lot of switches. And obviously I could emulate that with like a Raspberry Pi, not even a Raspberry Pi, just an Arduino. But we're not going to do that. We're going to do that with switches because it has to be fully mechanical because it's 1951. Before I strip down any of this paint, I'm going to make a little note in my desktop notes app and mark down everything that I know about the different paint colors, like white for this, all the different red striping, how far apart they are, where it starts, so I can exactly recreate it exactly how it was, because there's not going to be any of this once I'm done sandblasting. Here we are. I need to sand the putty, and then we need to put some reinforcements on this because I don't trust it, and I don't want to rebuild it again. Now I'm just going to take a quick file and clean out the inside of the letters, as some putty got in between where there shouldn't be putty. So I'm going to clean that up, and we should be ready for paint. My V. You son of a... genuinely didn't notice that broke off. Well, I guess there's a reason we're going to be doing some reinforcements. I should have done before I sanded them, though, apparently. God damn it. I dropped it and broke the corner. So we're going to have to cut out the excess to stick it up and glue that corner on and then putty that, because of course. And we're just going to glue this board along the entire bottom edge here. It's not going to add a whole bunch of support, but it'll keep those random pieces from just completely falling out, I think. It'll help support them because it'll be just fully glued the whole way along. And then I got these little wooden pegs here that I'm going to put to support the V and the U, that I glued on. So that's what we're going to do for supports. And with it flipped over, we can see just how bad this thing really is. This whole corner is missing. This definitely either spent some time outside or the barn it was in didn't have a very good roof, because that is gone. So that board's 100% going to have to be replaced, 100% going to have to be replaced, 100% going to have to be replaced. But I think we can save the trim boards, so let's just remove this whole side panel so we can use it as a template, which means we gotta remove it in as much as one piece as possible. So that's gonna be fun. It's detached. Well, there's still some wires I'll have to disconnect from this side panel. I forgot about them. All I did was pull out some of the large nails at the bottom, went to the back, and just gave it a yank, and the entire thing just popped off. So that was easy. But now I need to detach all the wires that are still attached to this thing, and we can fully remove it. Unfortunately, as you can see, it took some of this board with it, but it was already broken like that, so I kind of expected it would. And we now have, well, less of a pushover. Now we can work on remanufacturing this board, though I would like to save that because that goes right here. Let's glue this in place. I got the boards that are broken out of here. Let's put this puzzle back together. That took a lot of clamps, and I do mean a lot. As you can see, I went to the store and I got some beautiful high-quality flake board here. This will work perfect for what we're doing. We won't have any issues. This will paint beautifully. It'll look perfect. I'm just messing with you. I got actual decent plywood. Let's pull these clamps off and see if it stays together. And it held. So now let's move on. Well, not yet. I want to explain something. This gap right here, I don't want to 100% fill with wood putty, so we're going to actually cut a piece of wood and we'll put in there, and we'll just glue that in and fill the cracks with wood putty, because that large of a thing of wood putty probably wouldn't be that great. That's what we're going to do there, but let's get to cutting a new side. Okay, it has taken quite a long time. As you can tell, it is dark out. But this thing is fully cut out. It has been sanded beautifully smooth. I've sanded the surface, I've sanded the edges, I've sanded the corners, so you can touch this anywhere around here. You're not getting a splinter, which is exactly what we want. So I'd say the outline of it is done, but unfortunately it is too dark to keep working out here. So tomorrow we're going to have to cut out the actual coin door hole and cut all the grooves in it. I think I'm going to have to use a router for that, but we'll see. A dry fit, and it is looking freaking sick. That is looking dope. Now, you'll note that it is way too thick, but that's because we haven't grooved it down yet. That's why it's so much thicker than it should be. That's why it's staying so much above this trim here. Time to transfer over all these grooves into our new side panel. And to do that, we're going to be taking a lot of measurements, using squares and all that fun stuff, and then we're going to cut them out with a router bit. So, well, with a router and a router bit, obviously. So let's transfer them over. So many lines have been drawn. But that means it's time to start routing. Damn it. We're going to be rocking the handheld router. Let's hope we don't screw shit up. At least we have a flat edge here, so we can just clamp on a guide and just use this. So basically, I'm going to use this clamp here as a guide to run this flat edge across and just cut it out. So let's see if we screw it up completely or if it actually works. I already set the depth to the original, so we should be good there. There's nothing left to do but to send it. I fucked up. And I didn't actually do anything on the board. I mean, I fucked up. I should have done this outside, but it's raining, so I didn't want to do that. Why did I forget about the fact that, you know, wood sends sawdust everywhere? And it is done. I ended up not using the clamp guide because I couldn't clamp it in half spot, so I just ended up doing it by freehand. And it turned out sick. As you can see, I cut out the coin door and routed it in so we can put in a coin door. And it's looking perfect. Now, the only spot I really messed up, I curved up right here a little bit, but doesn't matter, you're never going to see that. And then we're going to have to use a chisel to square up the corners, but it is looking perfect. It is done. It slots in. It fits perfectly. All the slots line up, slot in. Everything's lined up perfectly except for right here. This is the only spot I screwed up. This curve here is a little bit too, I don't know what you'd call it, but It's supposed to stop at this board right here, so it's needs a little bit of filler right there, but that's no big deal whatsoever. This trim piece is just pulled out. That lines up perfectly. Bottom lines up perfectly. All of the interior boards slot in perfectly. It's perfect. I mean, besides that little bit there, but other than that, that's done. I wonder why my laptop never wants to work right. Marked out, so let's get to cutting. The new back is done. This is looking perfect. We got our groove cut in it to replace, well, this. So let's make sure it fits, and then we can rip off the bottom and make a new bottom and top. That fits perfectly, which means we need to rip this board off and cut a new one of that. And to do that, I think I'm just gonna, well, rip it off. Can't be holding on by much, can it? The answer is no. The bottom has been cut out. Let's see if it fits. Bottom fits perfectly with the new side and the back. They line up perfectly. Here's something kind of cool. We can actually read Pushover on this, which means they actually just painted the marquee while it was on this. That's pretty cool. Secondly, they messed up and they misdrilled it, so they just drilled it a second time. Now we just need to measure, cut, drill, angle a new board. Let's go do that. And the new top has been cut. Now we just need to drill a few holes. We need to drill a new lock hole and the 2 holes for the light. Now I have one fully cut out top. Let's see if it fits, and then we can actually start assembling this cabinet. I cannot stress how amazed I am at how well that fits. I mean, all the pieces. Like, I didn't have to remake a single panel, and that kind of surprises me. Everything fits together perfectly. Here is the marquee. Let's give it one final sanding as the finish off sanding off the wood putty that was last put on it. And we're going to do that by hand instead of using the power sander, because I think the power sander is going to take too much and might risk damaging something. So we're going to sand this by hand and get this finished. And it is ready for paint. Now we're going to do it the exact same way they did. Put a base coat of white and then paint the stripes over top of it. So, as you can see, the red is on every other stripe. So that continues all the way over. So, starting at the P with the red, and then it ends with a white. So we can easily repaint that. So let's get this cleaned off and throw on a base coat of white. You can see all of your imperfections. Yeah, those 3 there are not gonna do. So we're gonna have to do some spot putty and fill those pinholes. While that's drying, let's work on this here. As you can see, there's a lot of divots in this. This is honestly, I should have went with a higher quality board, but I didn't. So let's fix that. And to do that, we're gonna be just using some wood putty, and we're just gonna coat all of these divots. We're also gonna cover up any nail holes and all that fun stuff. So let's make this side perfect. Once this dries, then we're going to sand it down, and all the divots should be completely filled. Probably will be some pinholes. We'll probably have to do a second coat, but would have been better to buy a higher quality piece of plywood? Absolutely. I would have had I realized how bad this one was, but hey, we're making do with what we got, so it'll work. We just got to do some extra work. Now that we've made it so the cabinet looks like it was dropped in a jar of peanut butter, let's move back to the header. Let's try this whole primer thing over again and see what other places we need to put putty in. Now that that's done, that is looking perfect. Let's put the white on. I'm sure it'll look the exact same once I'm done, but oh well. Now let's throw some red paint on this thing and see what it looks like with the stripes. So let's go throw in some red paint. Second coat's on. Once that dries partially, we'll peel off the tape. So we'll see what it looks like here in a couple minutes. That is looking so sick. Unfortunately, the painter's tape did take off some paint in a few locations, so I'll have to do some touch-up work to the white, but that looks so sick. Now to let that red dry the rest of the way, but that looks awesome. And like, you genuinely cannot tell that it was, you know, completely custom rebuilt, that most part. Like, unless you flip it over to see the other side, where, you know, you can see where we bonded everything together. Like, that looks sick. Without the video proof, I'm sure, unless somebody flipped it over, they'd have absolutely no idea that that was custom built from what was left. But it's time to do some electroplating, and I don't really know much about it, but I got a container, I got some zinc, I got some sugar, I got some Epsom salts, and I got some vinegar. So let's figure this out. And if you're wondering why we're electroplating instead of painting or clear coating or whatever, it is because painting adds thickness, clear coating adds thickness, powder coating adds thickness, and that doesn't work for parts that interact with each other, so we can't do that. So what I'm going to be doing is zinc plating. Originally these were zinc chromate plated, I believe, but we're just going to zinc coat them because, well, I don't know how to do chromate, and I didn't want to blue them because originally they were a, you know, silverish gold color, so bluing would make them very much the wrong color. According to the thing I'm reading online, I need to fill it halfway with vinegar, and then I need to put my zinc rod in and let that sit for about 15 minutes before I do anything else to let the zinc, like, get into the vinegar. Okay, I switched to a smaller container because the other one just felt way too oversized and was going to use way too much vinegar and stuff. And the parts aren't that big, so I think I can fit them in here If not, we'll switch to the larger container, but for now, there's a lot of small stuff I know that needs zinc coated, so we'll just start with this. So I'm letting that sit for 15 minutes starting now. Well, there we go. I wonder how I'm supposed to know when it's done. I mean, it's bubbling, so does it stop bubbling? Hell if I know. It's been 30 minutes, let's pull this thing out and see what it looks like. Well, unfortunately, that's a very not even coat at all. So it said sugar is what makes it even, so I'm going to put some more sugar in, maybe a little bit more salt, and try another piece, because, well, I'm glad I used a piece that you're never going to see. Oh, no. I accidentally left this running overnight, which means, well, I'm out of zinc because I was pretty much out, and my alligator clip is gone. Let's see what happened to this metal. Oh, yeah, that's probably going to have to just be stripped down. Haha, damn. Well, that really sucks. I just realized I never explained that at the beginning there, when it was doing it really unevenly, it's because I had the positive and negative switched. So I was basically steel plating my zinc instead of zinc plating my steel. Yeah, don't do that. Let's get this cabinet ready for painting. And to do that, we need to sand off all of this wood putty we put on and then probably another coat. But let's get to sanding. Yeah, no, we're moving this outside to sand this. This is really smooth, except for down here where it was really bad. I had a couple spots chip out here. So we're actually going to wood harden this section because, well, it clearly isn't the strongest for some reason. So we're going to put some wood hardener on this, glue it all together, and then we're going to slap a second layer just in this section. The rest of it is beautifully smooth. Still 3 more coats, but this is now perfectly smooth through here. So that is looking awesome. Top is also looking beautifully smooth. Get rid of that stupid seam there. So it is looking beautiful. Now let's work on getting this front ready. This part doesn't really matter because it's recessed behind this, so I can get this side painted before this side's done. But this side I can't because it's even with this. So let's make this smooth. And, well, I couldn't do that. I can do this because this is just solid blue. This here, I have to wait till I get my printer done so I can get templates made to repaint that. This is sick. It is literally a doorbell. Unfortunately, these wires were chewed through, but it literally says patented March 3rd, 25. I'm assuming that's March 3rd, 1925. That is pretty insane. I think restoring this doorbell is going to be a whole separate video because I think this is going to be a real fun restoration. Unfortunately, this thing doesn't look like it was ever made to come off. They have a pin here, but it doesn't go the whole way through. So I'm assuming it's just a press fit pin that just goes halfway in. So there's no way to get that out without very destructive methods. So if we go on the inside here, there is actually a screw, but it's on a set screw on the inside here. I'm really not sure how I'm supposed to get to that. We'll try something, but I have no promises that I'm not going to have to drill out that pin. And there's a set screw, so it came out. So that means we can probably pry this off. It's probably not going to just pull off. Nope, not a chance. Unfortunately, that is fully seized in there, so I think I'm going to have to drill out these metal stems. I mean, I'm probably going to have to take them out anyway just to restore the thing, so god damn it. That's going to suck to get those out. That took so goddamn long. I tried everything, freeze spray and everything. The problem was, whenever they press fit this end in, they mushroomed out the end of the thing, so I actually could not physically pull this off the end. So that is just completely seized there. The set screw did absolutely nothing. I ended up breaking this off. That's no big deal. I can easily get that mounted back on there. And then this side, to press it out of this thing, which is what I ended up having to do, apparently my drill bit veered off of the actual metal insert and went to the side of it, which is why when I was pounding it, it didn't do anything because the metal rod was still the whole way through this thing. So I had to pound it until that metal rod sheared. So I'm going to use the lathe here to cut off the mushroom of this end. I'm sure this will spin around and not hit anything, so that'll be safe, I'm sure. But let's remove this mushroom end so we can hopefully remove the rest of this junk off of here. There we go. Perfect. The rod is beautifully cleaned up. I ended up just shaving down the extra of the old pin that was sticking up, so it should be able to slot back in, and we'll be able to put a new pin down through the hole that we accidentally drilled right beside it. So it'll be able to be pinned in nicely, and obviously still has the knurling question mark. I think that's what it's called. But that rod's done, so let's move on to the next part that we damaged. Well, nothing wants to go right. I put ever so slightest amount of pressure on that pin to try and press it out, and it just snapped the entire head off. Apparently, after they drilled that to put that pin in, there was barely any metal holding that on. So great. Now I gotta get the rest out of this knob and get the rest of the actual metal piece out of this metal piece. Awesome! What the actual I was even using a torch to heat this thing up. God damn, how the hell did I just twist that in half? Well, that rod's 100% gonna have to be replaced now. Great! Okay. I ended up having to cut off the old rod, and then I drilled it, and I tapped it with a new one. Unfortunately, when I cut off the old rod, I did nick it a little bit. But that's no big deal. I'm sure that'll be hidden somewhat somehow. But now that it's re-drilled and re-tapped, now I need a rod for it. And in my scrap bin, I found this nice rod here, which, amazingly, is the exact same thickness as that smashed rod. So let's tap this thing and slide it on. There we go. As you can see, we have the hole there. We can drill it out and put a new pin in then whenever we're done. But it's, well, perfect. Now we need to cut this to length and tap the other side for this knob. My favorite thing to do. Tap shit. Wait a goddamn minute. How the f did I screw that up so damn bad? There we go. That's a whole lot better. We're going to shine this up a whole lot more later, but it's done. That's looking awesome. We got to make this smooth because it's not, like, at all anywhere. So let's fill in all these dents and scratches, make this perfectly smooth and ready for paint. And the face has been fully peanut buttered, so let's let that dry and then sand that down. Okay, the thing's been spot puttied and also normal puttied, hopefully for the last time. Well, all of that looks good except for this corner. This corner was not out enough, so more putty, yay! We can throw a primer on this side a while and we can see if we need to putty anywhere else or at least how good it looks. So let's throw some primer on this side and be done with this side, hopefully. We got our first coat of primer on, let's let that dry and throw another one on. We're gonna be finishing the knob. As you can see, I've polished it to make it beautifully shiny. Now these indents here, I believe they were black before, as there's little bits of remnants. I'm not sure if it's dirt or if it's black paint, but I think it would look sick as black paint in those rings, so that's what we're gonna do. Let's drill these holes for these pins, put them in, and then we can paint those little marks on the inside. That is looking so good. Now I did throw a coat of clear coat on it. It's not gonna stick well to the polished metal, but hopefully it'll stick good enough. If it doesn't, we'll just polish it off. It doesn't really matter, but we'll see. I probably should have put that in before I even bothered polishing this thing, but let's try and get it in. We're going to use the microfiber to protect the face, put this in there, and just press that pin in. I think I got the hole lined up. We'll see. Yeah, that messed up the clear coat. Damn it. Oh well. Let's go polish this thing again. It has been polished back off. That clear coat was a pain to get off. Like, I am seriously talking real pain. But we're going to put that black paint back in there, and I'm not going to clear coat it because that was a pain. It's polished, so it should resist corrosion better than, well, just normal metal, so we'll see. That is done. It is looking awesome. Let's restore this drawer. As this front's ready for primer, the bottom's ready for primer, but this needs some work. I just did a quick once over the rag and actually discovered something rather interesting. While the faceplate is blue, obviously, the handle is actually a brownish red. So that's good to know. Faceplate is cracked. It's falling apart here. It's falling apart back here. It's falling apart over there. It's falling apart right there. The sides are peeling up. So this thing needs some major work. Actually, it's not supposed to be brown. It's supposed to be red, which does make sense. That matches the red, white, and blue theme that it already has going on. That's a bit further than I was planning on disassembling it, but now we can get each individual part perfect. Once that dries, we should be good to go. Okay, that board's now drying, that one's drying, that one's drying, and now this one is drying. Beautifully sanded, so let's throw a coat of primer on this thing and then paint it red. Everything should be dry. Now let's let that dry. And with that, we now have one beautiful red handle. With that drying, we can move on to another thing. Finish up the marquee, and to do that, let's pull out the rest of this marquee light, and then we can clean it up, put a new bob in it, and hopefully it works. I have doubts, but we'll see. I have never plugged this in. It looks super sketchy. It probably will blow up. But hell, why not? I grabbed this bob out of another machine. It should be good, as it worked before I pulled it, so let's find out. Don't try this at home. Just simply don't. Connected it up to this variac so we can slowly raise the voltage up to 120 volts, because I have a feeling this is just going to go bang, and I'd rather it do that at, like, 20 to 30 volts than, well, 120 volts. I did not expect that. I figured at the very minimum the starter would be bad, but hell, I guess it works. So I guess let's attach the pushover marquee that we finished repairing a while ago. Plug this thing in and see how it looks. And there we have it. Look at that. That is awesome. As you can see, the light coming out here in the bottom, because that would shine down on all the prizes that are in the actual pushover. That is awesome looking. Let's finally figure out how to build these stencils so we could finally start finishing this thing. I bought this thing to do those, and then realized that this thing requires a $60 a month software, which I'm sure as hell not paying. But a hop and a skip and a bunch of bullshit later, we happen to have the software now. Basically, I just take this into GIMP here, and on another layer, I just trace out all of those actual colors. Now here's the fun part. If you were good at the software, you could probably pretty easily figure out the size that you needed to cut this out at. If you look at this thing, I don't think it's perfectly straight on. which would obviously be causing my stuff to be all sorts of out of whack if it's not a perfectly straight-on shot. That means all of our stencils are going to be way off. Now we have some perfect bars that I can perfectly straighten the picture on, and hopefully get a straight-on photo of that. So I've redrawn this entire thing, which made me realize how weird this thing is. First off, I can't tell if these are his hands, or if they're like shoulder pads. If they're the hands, what kind of hands does this dude have? What the hell? Why does he have teeth? There's 3 little square teeth here. What the why is there like a chunk missing out of his face? I don't understand. Also, somebody clearly threw something out there, so you can see a splatter mark. Here is the base photo. Obviously, I didn't actually use the same colors here in GIMP because I just needed a solid color for cutting out. Here is the stencil for all the white. That'll do that. And then here's the stencil for all of the tan. I don't know why that's more of an orange, but that's okay. And then here is the stencil for all of the black. And then finally, the stencil for all of the red. This may not look like much, but I think it's cut out. Let's just take a look and see if our sizing is anywhere close to being correct. Close, but not quite. I think I'm a 1 or 2% smaller than it should be. 66% size, it works. Well, mostly. I didn't quite perfectly line it up, but that's basically the exact same size. So that's exactly what we need. Now, this isn't actually the part we use that part. So it actually took me a little while to realize that, holy shit, you're right. Like, there is some hair there. I always kind of just blended that in with the splatter marks that are all around here, but if you look really closely, you can just kind of see outline of hair. As you can see, boom. That actually adds quite a goddamn bit to that clown. There's the white. And now for the red. And it's done. Would you look at that? Obviously, whenever it's actually painted on the machine, it'll be painted on top of a pre-primered, pre-blue background, so it won't be, you know, painted super unevenly on a random piece of plywood. But that works, and it looks pretty good. Also, it'll be smooth, so we won't have to worry about the little running as the paint got in the seams and ran down some. Let's restore this 1925 doorbell that is actually off of our H.C. Evans pushover. And we need to fix it, because, well, it's very worn, and it unfortunately has a very large crack in it. But first, we gotta figure out how to disassemble this thing. I think if I just bend this metal tab or this metal tab over a little bit, I can pop it fully apart. Actually, it's even simpler than that. You just gotta twist it. This crack here is pretty bad. And it's such thin metal, obviously it can't be welded, and I'm pretty sure it's brass. I put a bunch of, like, old plumbing flux on there, and now we're gonna use some old, definitely probably lead solder, and try and solder that. Okay, well, that did not take much heat at all. Okay, let's see if that actually holds it together or not. Looks like it patched it down there where all the solder flowed, but up here it didn't. So I think I need to mount it in the vise at an angle so the solder doesn't just all roll to the bottom here. I'm gonna be honest, that worked better than I expected. That is perfect. That's exactly what we needed. That crack's nicely held together now, so now we can kind of sand this down, hopefully buff it, and get rid of most of that crack. Okay, there's the whole thing sanded with 220. Let's start going up in grits. 1500 grit. Unfortunately, while this side, the crack's pretty not that noticeable. I mean, it's a little bit noticeable, but I actually notice there's another crack on this side where this screw hole is, so I'm going to throw some solder on that as well, and then let's hit this thing with a polishing wheel. The inside may not look pretty, but the outside, sure, that's really hot. Holy shit, that doesn't even look like the same part! That polished out amazingly! And just like that, we have a brand new looking mirror finish button for our H.C. Evans pushover. This button is almost 100 years old, 1925. That is insane! And that looks awesome. I can't wait to see how that looks on this pushover when we're all done. Let's get some major work done. I'm talking paint. I finally got a paint match, so it's time to get this thing ready and painted. I took this part into Lowe's because this part is the original color, non-faded, because it was covered up. So I was able to get an exact paint match for what color this used to be. I also got some primer, so we can paint this thing and get it finally done. It has been fully primered on the outside. That's sick. We need to primer the insides of those, actually. Like when you primer anything, I found some issues, so I gave it a light sanding to knock down any bumps and anything. And I have a couple divots. There's this one here that needs filled, and we got a couple right here that need filled. And then we can throw another coat of primer on this. Now let's let that dry, and we'll see what it looks like when it's done. Absolutely, look at that. It is basically time to slap on the clown. Paint this clown on our 1951 H.C. Evans pushover. The problem is, we actually need to do one more thing, and that is actually add all of these white dots. As you can see on the original side art here that we haven't repainted yet, there's a bunch of white dots all over it, and that's intentional. Some might think that's overspray, but if it was overspray, it would have, well, all the colors, These, I'm gonna assume, were supposed to be some kind of like stars, so let's add them to our new artwork. And another coat of blue because we fit those dots. We'll try it again once that dries. Okay, I'm not gonna lie, it took way too many attempts to make those dots look somewhat correct. It is apparently really difficult to put dots down that look somewhat random. Let's actually put the stripes on the bottom of this cabinet next. Then we can work on the clown. And now we throw on the white. And the red paint's on, let's let that dry, and then we can peel all this stuff off and see how it looks. And unfortunately, it looks good-ish. From far away, it looks awesome, until you get close. And then you can see that I definitely should have used a better tape. It bled over into the white. Now, I'm not going to repaint everything for that. Oh, you can also see it bled at the top pretty bad. Basically, I'm just going to take a small paintbrush and just touch up the edges and make everything sharp, because the painter's tape clearly did not. So, I think it'll take a little bit more work, but that will look so good. I fixed the paint that was messed up down here, so that's all beautiful. Did have to cut out some paint around here, so this will actually close properly. So I gotta repaint that now because there were some bumps that was keeping that from closing. We've gone ahead and cut out all of the stencils, so we should be good to slap all this stuff on. And now for the paint. And the white is done, and that looks so good. Now let's throw the next layer on. And the tan zone, wow, that looks yellow on camera. But now let's throw the red on. And would you look at that? We have a clown. Now, there's some things that still need done. We need to add the, like, little white, like, glare lines on the balls and on the nose, but that looks so good! Let's see if we can build this thing a wiring diagram. The thing that I find is really interesting is there's no transformer in this thing, so there's just 120 volts going everywhere in this cabinet, unlike a pinball machine, like the EM machines, where they usually drop them down to like 25 volts. We just have 120 volts drilled right into the wood. So, that might not look like much, because it isn't. But let's turn this into something that actually is readable by somebody that isn't me. Let's go over this. Eventually I'll actually make it a digital copy. But let's go over how this is supposed to work. Okay, starting here, obviously we have our AC in and our 10 amp fuse, which, you know, we have our fluorescent lamp, and we have our tilt switch stuff that was right here, and our tilt relay that should be there. But most importantly is this absolute mess down here. As you can see, we have a left and a right motor. Those are these two right here that would move the arm back and forth. We also have the switch that would be on the knob on the front, and our limit switches that are connected here or for the edges. These are normally closed. I didn't draw them as normally closed switches. And down here is the button on the front, which is actually that button right there, that would trigger the arm to run. That's where we have a slight issue. As you can see, this motor right here is actually this main motor right here. And these four switches here are the four that are on this thing here that get triggered while this rotates for something. I'm not sure how that's supposed to all work. The main thing that we need to care about is this right here. These 6 connectors right here. That is these 6 connectors, which is what the coin mech stuff would attach to, and that's what we're missing. So we need to figure out what would need to be attached here to make this thing run. Here is the schematic for the actual cabinet, now that I've, you know, made it. And as you can see down here, here is that coin connector, and I don't know what connects to it. Here's the way that I came up with, but I don't think it's the most efficient way, while I do think it would work. Here's all the pins we have on the connector. We have an AC live, an AC neutral, we have the motor 1B switch, which is given AC neutral when the lever is all the way up while the motor is spinning. And we have this one here, which needs the AC neutral for everything to actually function. And this is the AC neutral that's always on when the motor is moving. Now, the way that I've come up with to do this requires 2 relays, which kind of sucks. I'd like to only have to use one, but I can't really think of a good way to do that without modifying the original hardware. But the way that I've come up with is pretty simple-ish. Basically, whenever a coin is input for a split second on the switch, it'll trigger this relay for a second, which will bridge both of these connections, which will then self-lock the relay on, which will also bridge our AC neutral to our M2, which is the switch that needs to have the AC neutral to power all of the motors for whenever you're moving the lever and pushing the button. And then this relay is kept on indefinitely until the connection is broken with this relay right here, which is a normally closed relay until it gets the AC neutral from this switch here, which is the switch that is triggered when the lever is all the way up, which then breaks that connection, breaking this relay, resetting everything to be, well, used again. This is what the prizes would sit on, and then they'd exit the door right there. But we need to clean this thing up and get it repainted. As you can see, it used to be a nice tan, and it used to have some random gold stars all over it. So what we need to do is knock off all this loose stuff. I think for this piece of plywood, I'm just going to peel off this first layer, and that'll be fine. But this one over here is unfortunately going to have to be replaced. Now, my new plywood is thicker than the old stuff, so what I'm going to do is we got a planer. Sometimes you don't have the right tools, so you got to use the wrong tools the wrong way to make the right tool. Now that we're quote-unquote planed down, we can put this in and it'll be the exact same thickness as it was originally. Now with that fully sanded inside, let's throw some paint on it. And the first layer of primer is done. Yeah, no, that's not right. That dried way darker than it should have, so I went and got the proper paint match, which, as you can tell, is a whole lot lighter. So let's get this stuff painted. That looks much more like sky blue. Looking at what was left of the old paint, there appeared to be 3 different sizes of stars. Really small, medium, and large. And they seem to just kind of be randomly placed all throughout, a few inches apart. So, stars. As you can see, the original was a very shiny gold. Unfortunately, this is on a faded piece. I'm not sure what happened to my unfaded piece that I used to paint match. But luckily, I managed to find some, well, gold spray paint. And now there's a bunch of stars. Ignore the random blue spots. That's where I had to actually repaint the star. The star got messed up. Apparently, I could use a stencil for 1, maybe 2 times before it got messed up. So, that was a real pain. Once those dry, it should be the same color, and then I can just put new stars on all those spots. I think there's a couple on that one that'll have to be repainted. Same with that. And then, once this is dry, it's, well, done. I actually can disassemble this one here, which is good because this one's actually apparently a wet system. As you can see, there's a fill plug up there that I removed the screw, and there's supposed to be oil sitting here in the bottom that obviously is completely dried up. Luckily, however, all the gears appear to be in pretty good condition. One thing that I found really interesting is this gear here is actually just another gear press fit into a larger gear, which I was very confused about for a minute because all the other ones are just one-piece gears, but I imagine this was probably actually some kind of failsafe. For over torque, it would just, spin out the middle gear. That is my best guess, but I honestly don't know. Hey, if you clean it enough, it actually says oil. There we go. And as you can see, it's a bit more shiny now because I actually went ahead and clear coated it, so hopefully the prizes rolling on it and stuff won't scratch up the paint. So, this is looking pretty damn awesome. So these parts are done. The only issue is these 2 metal rods aren't because I am out of sandblasting media. I'm not sure where it went, but I'm gonna have to get more before I finish those. Now let's make these things look a little bit better by polishing these things up. That is looking so much better, but we're still going to polish this a little bit further, but now let's do that one. That's looking pretty incredible, but again, let's go polish these things and make them absolutely shine. And now we polish. It just ate the piece, goddammit. There we go, that looks absolutely incredible. That is looking absolutely incredible. This thing's gonna look awesome, and this is a nice shiny white. There's a surprising amount of metal that I missed in this when I previously sandblasted the metal bits. Here is all the bits of metal and all of the hardware. People have told me to just put the hardware in a rock tumbler instead of spending 3 hours trying to sandblast it, so we're gonna try that, and if it works, that'd be awesome. All this stuff has been sandblasted, so we'll have to zinc coat this here eventually. Also went ahead and polished these 2 rods. Hey, that looks like it might have worked pretty well. I'm going to use this hot plate to dry everything out. I'm not sure if these yogurt cups can hold heat, but we're going to find out. They can, in fact, not hold the temperature of one of these on max. This thing reaches over 900 degrees Fahrenheit on max. That makes sense. The good news is, though, it's all dried out very nicely. Well, here's the thing. It worked really well until I blued them. And by bluing them, I mean I got them so hot they turned blue. The board right here can actually just be put back in. It was only removed to get a paint match off of, so we can just slap this back in. We need to finish these boards up here. We need to get them prepped. These are the trim pieces that go around the bottom edge. However, as you can see, these things have seen better days, and I also need to punch out all of these rusty nails. Now, I know a lot of people are going to say, oh, you should probably just replace those boards, and I agree. However, this project, we're trying to reuse as much of the original stuff as possible, which means we got to repair these. Now, let's go ahead, and this thing was originally painted white, so we're going to powder coat it white, mainly because I actually saw a pretty cool technique on some restoration videos recently where they used powder coat instead of paint as it fills the divots in the metal a little bit better than the paint would. So we're going to powder coat this white. It's done and looking absolutely amazing. I went ahead and put this in here and unfortunately realized something. That top needs painted this blue and add stars added to it. I didn't even realize that. That's awesome. Realize 2 things. 1, you shouldn't wait a year to do a project, well, to finish a project, because, well, I don't remember how the hell this shit goes together. Thank God for the videos I took. Secondly, I am missing some metal, which means I gotta figure out where they are. I'm pretty sure I know where they are, and that is buried under like 20 cabinets. Let's note these feet on here because they finally arrived. Now, originally, this did have basically the same things, but they were basically all missing. I think I had 1 mount left, and that was it, and it was rusted to shit. So, all new ones it will get. Now we simply screw all these in place. There we go. Now I'll flip this thing back over. Now, admittedly, I should probably primer this wood bottom so it doesn't go bad. So we'll probably do that at some point. I honestly thought it already was, but I guess it isn't, so. Now let's finish working on these trim boards from around here. In the last part, we puttied them, Now we need to sand them down to actual pieces of wood again, then sand it down, now to add another layer of putty in a few locations. Unfortunately, I couldn't seem to find the correct size pieces of rubber that I wanted, so I bought a ton of the wrong size that we're going to use and should work. They're the correct size outer and inner diameter, they're just not near thick enough, so we'll just have to stack like 20 of them on top of each other. Some zinc, and a broken power supply. And by broken, I mean it works, but sometimes it shuts off, and sometimes the voltage randomly goes up and down, so it's perfect for this, but I would never hook anything actually valuable up to it. White powder, and some more white powder. Still very slowly zinc plating, but let's polish these two pieces that should already be done. And to do that, we just simply take some fine steel wool, and we're left with the beautiful zinc finish. And here's a piece that I also rubbed with the exact same steel wool that's just base steel, and as you can see, there is a bit of a color difference, so we know that this is nice and zinc coated. We have a slightly large issue. This right here is the motor that runs basically the entire machine. I was mounting it, and something torqued weird, and this corner broke off. Well, I was able to reattach it with some simple JB steel weld, as this is aluminum and, well, cast aluminum, and I can't weld cast aluminum. So that's not the issue. The issue is the motor itself. While I was repairing that corner mount, I noticed the motor doesn't turn. When there's no gears in here, this is just a straight shaft right through the motor. This should turn pretty easily. I can't get it to budge at all. Turning the fan, it just free spins on that shaft. That shaft is not spinning. Okay, I have this wired up. Don't do this. I'm a trained professional. Well, don't do this. Yeah, we're getting nothing out of that. What I'm going to be trying next is actually using this ultrasonic cleaner. As you can see, it is very slowly heating up because it is very cold outside right now. I've ran this through about 3 cycles, I think it's been. Oh, that's really hot. Holy shit. But it is looking a lot cleaner. That is for sure. It's definitely not the same color water that was in there. Let's see if this thing will turn now. I don't think it will, but hey, we'll find out. Can I put this somewhere? Holy shit, actually it just turned a little bit. Oh my god, that actually worked. I cannot believe that worked. It's a free spinning motor. Well, damn. We're gonna throw this back in for one more cycle now that this thing is spinning just fine. Hopefully that'll clean out any dirt that was stuck in around there now that it's broken free. That is actually incredible. Okay, we are running. So it needs a little bit of oil, but it works. Now let's make sure with all the gearing and mount it up, it works. And it does! I messed something up. There's a piece of metal that goes to it, and it actually goes right there. However, I kind of hit it with a saw. First things first, we need to bend this thing back into shape. And now we need to do some metal bondo, aka welding. And there we go, nearly perfect, and considering the rest of the metal's condition, pretty good. Now we just need to re-drill that hole. And there we go, it's looking pretty much perfect. Who needs a saw stop when you have a 1951 HC Evans pushover? Now this thing is really pitted all over, and I would just powder coat it and throw it in the powder coating oven, but it won't fit, so we're gonna have to spot putty this thing, unfortunately. There we go, and now we just need to let this dry. All that's on it right now is some sandable primer. I don't actually have a paint I want to use on it yet, but as you can see, now, it's almost as if no idiot accidentally hit it with a saw. One of the first things I'm missing is the metal shaft that goes right through here. It's a simple little metal shaft with 2 grooves in it. For now, I've 3D printed a replacement, but if we finish the machine before that part turns up, we're gonna machine a new one because ultimately that's not a difficult part to machine. And finally, I'm missing a second limit switch. This one's actually broken, so we're gonna have to take this one apart and do some repairs anyway, as that leaf switch is unfortunately very much broken. That's gonna be a fun fix. But since I have lost the original second one, we're gonna make a new second one. Obviously, the leaf switch is just a leaf switch, we can get one of those, but this metal frame is where this comes in. This may look 3D printed, and that's because it is, but this is a template to cut out this out of metal, so we can fold it into the exact right metal shape, and then we can just mount a leaf switch on it, and get some spring steel and bend it into this shape, which again, should be very simple. And now with a few simple bends, and boom. A replacement switch base. Right here we have a bunch of the wood pieces that I've been sanding, wood filling, primering, more wood filling, and we've gotten it down to, I think, the final coat on a few pieces, just to skim fill a few cracks and stuff in the wood. So as soon as this stuff dries, we'll get this sanded down, primered again, and then get it painted. And everything is, hopefully, got the final coat of primer on it. As soon as that dries, we'll slap some real paint on this stuff. Now we're at the first coat of blue on this stuff, so as soon as that dries, honestly, we might have to put a second coat on. If not, we'll get ready to slap this stuff on the machine. And there we go, we now have this ring around here. Definitely adds some detail, definitely looks nice. We also put this on here. Need to glue here, here, and there. But our frame here for the glass is looking absolutely beautiful as well. What we need to do is paint this thing white, and then we'll put our red stripes on it. You don't want to go the other way because it's going to be a lot more difficult to put the white stripes on the red than put the red stripes on the white. And there we go. We have that now painted white. Now it's time to add the stripes and paint it red. While we're waiting for that to dry, why don't we get this bar mounted in here? This is kind of the major point of the pushover. It's what does the pushing over? There we go. Nicely mounted in. As you can see, it's kind of in the up position, but this is basically how it works. There's springs in this so I can actually move it, but normally it would start all the way back here, and then you'd move it around with the joystick to side. To line it up with the prize you wanted to win, you'd hit this button, and it would swing up and hopefully push your prize out this hatch. Awesome. Just a little bit more to go, and maybe we'll be even able to test this thing. There we go. That's looking absolutely beautiful. Now we just need to finish this piece of metal trim for right here so we can cover up all these ugly holes. I actually wrote down how this should be painted, the spacings, which side starts red, and where everything, so I can make this exactly how it was originally. I also wrote down that these switch covers were apparently red, so we're getting those primered up and get them painted red. Look at that. That is looking absolutely fantastic. Now we let that dry the rest of the way, and we can slap that thing on. Look at that. This machine is absolutely coming along. This looks absolutely incredible. We're supposed to have switches on each side to tell it whenever it's reached its limit of its edges. However, we have two issues. One of them, I don't know where they went, and the other one is broken. Here is the switch that is broken. I've disassembled it so we can actually see what's broken, and it's this. As you can see, kinda, that broke off. That's supposed to be quite a bit longer. That is a problem. Fortunately, going through my Switch collection, not a single one of these is going to match up properly. I need to modify this thing since I can't find one the correct size. I just realized something incredibly, I don't know if I want to say funny, but if this piece of insulation paper, which has worn through, so I'll have to replace it, isn't there and isn't covering this entire beam, this entire thing is charged with 120 volts AC. And it sticks out into the cabinet. That's genius. Luckily, I happen to have a roll here of fish paper that I bought for another project, so let's cut out our new insulation flap. Now, with our new piece of insulating fish paper, let's put that contact that's somewhere on here back in that hole and make it fit. There we go. New contacts in there. This should work pretty damn well. Also got a piece of insulating paper to go underneath, because depending on how far you push this down, it might come in contact with this, and again, energize the entire switch with 120 volts. To build this wire thing, I bought a whole bunch of spring steel of the same thickness, so we should be able to bend this into the right shape, and since it's spring steel, should hopefully hold that shape. It turned out way better than I expected it would. Okay, and it's nice and springy, so that's perfect. Now we just need to add our holes to this thing, and there we go. We got our original and our recreation. Switches are installed with their covers, so those are done. See this here? This is supposed to have a little metal tube attached to it that sticks out a little bit, I believe actually this direction, and it attaches on the other side of this knob. Unfortunately, that thing got absolutely demolished while removing this joystick, as whenever they installed this thing from the factory, they mushroomed over the end, making it, well, basically impossible to remove, which is why we no longer have that piece of metal with us. So we need to make a new one. That is ridiculous, the equipment required to work on arcade machines these days. And here's our new steel bushing that should fit in there perfectly, and it should be the exact right size. Oh yeah, that is a perfect fit. Awesome. I almost forgot to tap it for a set screw. That would have been annoying. Basically, this is how I'm going to attach it. I'm going to use this fancy spike here to expand that into this ring, which should hold everything in place, which is pretty much exactly how it was done originally. That is looking absolutely phenomenal. I also realized at the beginning of the video, I'm pretty sure I called that thing a bushing. It's quite literally the opposite. It's supposed to move with this, so if that slips on that, that's a bad thing. That's why we have to add that set screw there. Basically, when you move this joystick, it rotates this to hit a switch on either side to tell it which direction to move the pushover out. Switch is hooked up for our joystick. Now we need to hook up our spring to keep that thing centered. That's absolutely beautiful. Have the parts to hopefully build this coin door and actually test this thing. Now, you may be saying these are not from the correct time period, and you are absolutely correct. The issue is this machine runs on 120 volts. So I can't just take a relay out of like a pinball machine, as those usually run on 24 to like 48 volts. And if I were to use one of those relays in here, it would burn out and be an absolute fire hazard. So unfortunately, we're going to have to use modern relays until I happen to maybe come across some old 120 volt relays, but they're going to be rather difficult to come across because I don't even think the ones in here are rated for 120 volts. I think that this thing is just a fire hazard. We'll have these just mounted to the door, so I'll mount it in the original cabinet, but we'll have to remanufacture a door. We'll have to get a coin mech, which if you saw a previous video, I think I have located a coin mech I'll use for this, so I think we're getting really damn close to be able to plug this thing in. That's actually a real concern. It's probably a good thing this didn't take off. From the live switches over there to this knob potentially being live, there's a lot of dangers with this machine. The only thing preventing that knob from becoming live with 120 volts is those little bits of plastic or bakelite on the ends of those switches there. If either of those break off and this gets rotated, that'll probably come in contact with that, making this thing live with 120 volts AC. That's very not good. What we're going to be doing instead is we're going to replace this 2-prong, lamp connector with a 3-prong connector, and we're going to run an earth wire to every bit of metal in this. Therefore, whenever this would actually come in contact with that switch, it would just blow the breaker. It's still not as safe as it could be, but it's going to be a hell of a lot safer than the way it is now. So, I'm going to have to break the rules a little bit and modify it a bit, but it's only adding a green wire running to everything in here. Now, unfortunately, I've never had the doors to this machine. They didn't come with it, and I didn't cut new ones whenever I cut these pieces. I probably should have, but I said, and I'm pretty sure I quote, "I'll do that later." Now, we need to turn these 2 blocks of wood into the negatives for those. And there we have our 2 doors cut out. Now we just need to countersink them in. And there we have it. We now have some coin doors. However, there's no way to keep them from coming out the bottom yet because we still have to put a metal bracket on the inside there that'll slot in place on both of them. But before we do any of that, we need to take these locks back off, get these things puttied up and painted. So I'm looking at this photo to try and see how I build this coin mech area. And as you can see, we have about 2 pixels of, I assume, maybe a lock. We have about 3 pixels of what appears to be the coin input, and possibly 1 pixel of what appears to be the coin return. That's not that helpful. Now, for a coin mech, we're going to actually seal this coin mech system off of this door, off of this thing that we got in that lot of random junk. I was never able to identify what this thing came off of. I think it's from around the same time period. This is either a dime or a nickel unit, so one of those two. It should match up pretty well with the time period of the machine. So let's steal that off, and we'll install that on our new coin door. This is United Manufacturing Coin Mech, which actually should help me identify what this machine came off of, but obviously, United Manufacturing is not HC Evans & Co. So, I have 2 options. I can either put this project on hold even longer and not use this coin mech, or I can use this coin mech. And I think, obviously, we're going to use this coin mech. It's not like I'm modifying any of the original wood to use it. All I'll be modifying is the replacement door that we just built. So if I ever find one that obviously isn't from United Manufacturing Co., we can just make a new coin door. And here's where we need to cut out. This center spot here is where we need to cut the whole way through, and then this section here is where we need to ramp down like that there. And obviously our coin return spot right there. I managed to mount this as high up as I can, because I need to have room underneath here for the coin box, because as you can see, there's not much room underneath here for the coin box. It's already going to be a quite rather shallow coin box, and I'd say that's a pretty damn good successful fit. That actually works really well. I unintentionally lined that up almost perfectly with that. Now we just need 2 more things. Locks, and the piece of metal that goes on the bottom. You give them a weird bend so everything slots in nicely, but once I line it up, slots in absolutely perfectly. Time to do some wiring inside there. So I went ahead and got a whole bunch of different colors of, well, fabric-coated wire. Now, this is modern fabric-coated wire, so it's actually just wire with normal insulation with then fabric on top of it, which is why it looks like 16 gauge. When it's not 16 gauge, it looks absolutely massive because there's a absolute stupid amount of insulation on it. If you look in here, you can see that unfortunately something has chewed the wires off that go over to the button, or cut them off, I'm not sure which. But we need to, well, reattach those to over there where the button goes. Now we have our fresh new wires here. Let's put that button on. Now we need to replace all of the wiring for the coin door, which requires, you know, that old wiring diagram we made quite a while ago to add a bunch of coils and such. I also found a matching connector to plug into that connector there, so we can have everything behind the coin door actually be original. There we go. Now we have that wired up. That should be done. Not done the safety changes to that yet. I'm going to actually replace that metal ring there with a piece of plastic, but I haven't done that yet. We'll have to do that here in the future. We're going to be using this nice 3-prong plug here because we're actually going to be running ground wires or earth wires to a bunch of different places, so we need that nice 3rd prong. As you can see, we're all wired up. So, I think in the next part, we're going to plug this thing in and see how many breakers I blow. % sure I wired stuff wrong because a couple of the wires broke off of the switches over here and stuff. And I still haven't back together the way I think they went, but if it doesn't work, we'll actually have to go in and figure out the wiring for this and actually redo everything. But we also haven't ran our earth wire to everything yet, but who needs that for testing? Let's plug this thing in. Okay, we are 1 switch away from having 120 volts run through a machine that hasn't had power in many, 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 many years. And holy shit, we got light. It didn't catch fire. Hell yeah! Holy shit! Also went ahead and grabbed a thermal camera just to make sure nothing's getting unreasonably hot, and so far nothing's getting hot at all, so that's a good sign. See, this is not in its home position down here, so it should have automatically homed itself, but it didn't. So, yeah, let's put a nickel in the coin slot and see what happens. Here is where everything goes horribly wrong and blows up, most likely. No? Oh, shoot. Had movement for a second. Huh, that was weird. So it would appear, unfortunately, our tilt solenoid is bad. I decided, hey, let's test that out, and shot sparks out the end, and obviously no longer works. There's no resistance to the coil. So that coil was bad. I don't know if it was dead shorted or what. I never actually checked it. Also, some voltage getting through things that shouldn't get through. Like right now, there's no coin in it, but it's very slight. There's like 30 volts going to things that should not have 30 volts going to them. So looking at the schematic, I unfortunately did wire a few things backwards. Luckily, well, not really backwards, just simply wrong. Luckily, it didn't seem to have damaged anything. Luckily, I made this schematic, well, back before I messed up all the wiring. Appears I actually only had one wire messed up that should have been here. I hit over there and vice versa. And I believe our only going left issue is because this wire here was broken off, so I've stripped it back, and we're going to solder that back onto that switch there, and we should be able to, well, properly move again. Now that we're wired correctly, hopefully, we have stuff moving. It should stop here eventually. Yeah, now I think we're rocking. That's sticking out a bit far, but I'm sure I just have stuff clocked wrong. I also didn't have that door locked in place properly, so now everything is set up. You have no movement from that. There we go. We no longer have a random backfeed of voltage. That was due to having stuff wired wrong. Awesome. Let's put a nickel in, see if this machine works. Moment of truth. Didn't hear anything. Gonna have to do something about that noise, but probably need some oil. Holy shit! Damn. So close. Oh, actually, I know exactly what that is. I was testing continuity and disconnected that button. All I have to do is reconnect that, and I think we have a 100% functioning machine. Yeah, wire's been reconnected. We have no power, as we should. Now we put a nickel in. Now, moment of truth. Please don't shock me. That could be a problem. It's not locking on. Do I have to hold it long enough and then will it lock on? Yeah, okay. It stops, right? And it comes back! Holy shit! Yes! We have a 100% functional pushover! Holy shit, that is absolutely amazing! Let's see if we can win this soda can. Probably just gonna knock over. I need to add the extra piece of claw that's supposed to go into there. We'll just pretend that goes up. Yeah, look at that! We won a Dr. Thunder. Holy shit! This is absolutely incredible. Now that I've seen this thing actually fully function, I have so much more motivation to actually fully finish this thing. After a little bit of oil, that moves way better. That is absolutely awesome sounding. Make sure that still works. Make sure it clocks right. That opens up. That goes up. And it comes back down just like that. That is absolutely magnificent. Now, in all of my geniusness, I didn't get any green wire. All I got was white, black, and blue. And everything in the cabinet's already white, so I guess we'll use blue for our earth wire. I don't really want to use black because that'll look too much like hot, but I think blue will be good enough. Basically, we need to run our earth wire to everything that gets, well, electricity in here, so we're going to earth that motor, that solenoid. Trying my best to follow the original wiring path and original way it was wired, besides the fact that the wire is like triple the size of the original wires because, you know, properly insulated. And also, I'm gonna get some twisty things and probably like attach all of the wires together so it looks, well, natural enough. Sure is conveniently left an open connector on that, well, twin door connector. Almost like they designed it for this. If that was possibly believable, considering most houses at this point didn't even have a third prong. There we go. It's been rewired to have, well, earth run to pretty much everything that's important. The only other modification that we will be doing, well, for now, is also going to be adding a plastic wheel on that, just to make it slightly safer and insulate the handle a little bit further away from 120 volts AC. This right here moves switches that carry 120 volts with the smallest bit of wood insulating it from those switches. So we're actually going to make this out of plastic to help not kill the people trying to play this machine. There we go. We now have our new 3D printed one of these things, so let's get this thing installed and make sure it works. There we go. Now this more than just a tiny little piece of plastic or wood insulating, well, the joystick from 120 volts AC. I went through a bunch of my previous videos, and now I know it's supposed to actually hit this stopper. A spring. Box 5 looks like it has a spring that'll work. Now, our stops are functional, so we can't keep going whenever it hits the edge, which is absolutely awesome, and it's great to have those functional. Plus, with that spring, if something gets caught, you know, there's a little bit of flex in it before you break something. Try and win this awesome prize of a capacitor. Yeah, roll right on up there. Easy. It fell out the back because I don't have a back door on this cabinet, but easy win. Now let's say I missed. Let's make sure that thing will flip nicely over that thing instead of getting caught on it. Just like that. That is perfect. Okay. You may look at this and say, this is the most unsafe thing ever. This is terribly unsafe. And that's because I'm actually not running it with the safety cover that they originally designed this to have. So let me install that and you'll agree that this thing is incredibly safe. Originally, this had a piece of fish paper over these terminals right here. Yes, I'm serious. Well, I don't actually know if it was fish paper. It kind of didn't exist after I took it off. But we're going to put fish paper back on it because at least this is an insulation paper, unlike what they could have had here. I don't actually 100% know. Look at that. Now this is the most safe cabinet you've ever seen. Now ignore the fact that all 3 terminals are still very much touchable right here. Nothing was covering those, but at least these ones are no longer touchable. Extremely safe. When I got this thing, it did not come with a back door, and that's quite a problem because the prizes you win would come out here and most of the time hit against the back door from falling out and go down there, but without a back door, they just go flying out the back. So we need to build a back door. Interestingly though, while it has 2 different sections, it actually only was originally supposed to have a back door for this top half. The bottom half was just originally left open, you can tell, because it didn't actually have any sort of slot or anything for it to actually sit into or attach to. While up here, it did have a nice little slot. I've been trying to figure out if this back door would have originally had a lock on each end over here, or one in the middle. However, I'm not sure, but there's not really any lockware in the middle, and there's what looks like might be a little bit of lockware right there. So I'm gonna assume we probably had a lock on each end, which would make a little bit more sense, as I think a lock right here might get in the way of this door a little bit. Using this standard lock and paw, we can kind of figure out exactly where the door was by lining it up with that wear mark, the lock, so we can figure out exactly how far it is from here and here to figure out how to place this lock on a door that was probably just free-handed from the factory anyway. Is this a comical amount of work for this? Absolutely, but we're doing it anyway. We're replacing these 3D printed parts. We're going to replace this piece here with our nice new fancy square pieces of acrylic, and we're going to replace our 3D printed piece here with a nice piece of brass. Now we just need to make this out of one of these acrylic bars. Apparently it doesn't cut very well in a wood saw, but it doesn't really matter because we have to shape that end anyway. There we go. Now we're going to light sand this to get rid of as much of the cloudiness as we can. Now we're down to just a haze. We're going to polish this and get rid of that. I'm not gonna lie, that turned out a lot better than I expected it would, so now we gotta drill some holes in it. That looks absolutely beautiful. Now we need to replace this bit of 3D printed plastic right here with a nice piece of brass. There we go, we got our piece manufactured. I just need to put the 2 C-clips on that, and this part will be done. There we go, that looks absolutely incredible. One more step to getting this thing complete. The one thing I think I've been convinced of is to leave this side original. Originally I was planning on redoing this side once I finished that side so I knew where the clown went, but I think I'm going to leave this side original because the more I do to this machine, the more I realize this doesn't look like it's 70 plus years old. At all. So I think leaving this original will help give a good reminder of what this thing used to look like. If I was going to sell this machine, I'd probably redo this side as well just to make it look, well, as good as possible. But honestly, for my personal use, I think I'm going to leave this side original. I can always redo it in the future if I want to, but you'll never have it original again. What I'm going to be doing is putting on this trim piece right here. While I'm leaving the rest of this side original, I did go ahead and redo this end piece because it was like completely missing like half of it, so it has been restored and sitting on this shelf collecting dust for a while. There we go, we got its bottom skirt fully reinstalled now. Originally, I was going to get a piece of glass cut for this thing, but I did a little bit more looking, and the only piece of glass I'm going to be able to fit in that slot is an 1/8-inch piece of glass. And an 1/8-inch piece of glass that big is going to shatter so easily. Which, to be fair, is probably why it's missing. Which means we're going to be putting in a piece of plexiglass. I know, but at least it won't shatter into 1,000,000 pieces immediately. And there we go, 1 piece of plexiglass installed. That looks absolutely fantastic. It's a little wet right now because I just washed off all my fingerprints, but ultimately I would have much preferred a piece of glass, a whole lot more scratch resistant, just ultimately more better looking. But the issue is, again, a 34-inch by 16-inch piece of 1/8-inch glass would not last very long. The other option is to put in a piece of tempered or laminate glass, which, I mean, technically then you get the advantage of glass, but technically it's not original how the machine would have originally been. So, I mean, basically the same as the plexiglass, just with scratch resistance. The issue is with that is, those are incredibly expensive to get custom sizes because you can't get those at a local glass cutting place. You have to special order in that stuff because you can't cut tempered glass. So you have to get it tempered at the size that you need. And that would probably run me well over $100, and I'm not made of money. I pulled out the plexiglass, took off the back door. Now we need to disassemble a bunch of stuff because, well, we're ready for clear coat. I went ahead and also did the little reflective bits off those juggling balls there. So those are all ready. So it is fully ready for clear coat. So we just have to disassemble it, clean it, and clear coat it. This is the clear coat we're using. It is a matte clear because originally this thing would not have had a clear coat. It would have just been the matte paint. So we're going to be using the matte gloss just to help protect that paint, which also helps because since it's not a gloss paint, I don't have to be very, very particular of how I spray it. The matte paint is a lot easier. I also went ahead and did all of the accessories that are around here and put them back to let them dry. I'm gonna go walk away before I die of paint inhalation, and hopefully when this dries, we'll have a beautifully done machine. The one thing we need to do now is repair the tilt coil. This thing right here, unfortunately, is burned out, and we need to fix that. Here is that coil. It is a straight 120 volt coil, which is fun, and it burned through right there at that wire that we will not focus on. But as you can see, a bunch of the enamel is gone from this wire, so this wire is all just shorting out together. Top insulation disc and bottom insulation disc kind of shattered on me, but basically we need to rewind this thing. I'm going to use some 3D printed insulators, and I guess rewind this with some new wire. Wish me luck. And there we go. Let's see if this works. I kind of doubt it. I didn't do the best job. I just put this thing in a lathe and let it pick up wire where it wanted to pick up wire, and I also didn't count at all how much wire went on. I went until it looked about as thick as it was originally. Moment of truth, 120 volts. Yes! If somebody tries to get an illegal prize by tilting the machine, this rolls out, hits that button that triggers this solenoid, which pulls this arm in, so whenever this gets lifted up, it just slides in that slot instead of lifting this arm up, so it doesn't open up this door to let the prizes out. And moment of truth, we have the machine on. If I were to go and tilt this thing, it, should do exactly that. Holy shit, we did it! We have a functional tilt mechanism on our 1951 H.C. Evans Pushover. This is a super awesome machine. This one was a lot of firsts for me. I had to do a lot of stuff that I have never done before on this project, so there's some stuff I would do different if I was to do it again. It was the first time I've ever done this kind of stencil stuff. I bought a vinyl cutter specifically for this machine, and I didn't do the best job. If you look really closely, some of that stuff doesn't look great, but you also got to remember this stuff would have been done with 1950s technology, so I probably did it better than they did anyway, because they probably just threw this together in a factory very quickly using just normal stencils, so their stencils probably weren't much better than mine. Today, we 100% finish this 1951 H.C. Evans Pushover. Bought a machine at auction that doesn't exist. Hear me out. This is supposedly an H.C. Evans pushover machine. We need to replace this random string that I put in here with a new string. I got this Kevlar string, as I have absolutely no idea what the string would have been originally, but this seems like a little bit better of a fit. There we go. That string looks a whole lot nicer. And with a 50-pound weight rating, it shouldn't snag and break on anything too easily. Now we need to put some locks in this thing. As you can see, it already has locks, but they're all mismatched, so we're going to put in a matching set of locks for all of these doors. Actually, I don't have any, like, 1950s period correct cheapo toys laying around, so I have to watch thrift stores for that, so I just threw in some random toys that I found laying around in here. And there we have it, one finished 1951 H.C. Evans Pushover. A few people have mentioned putting a diffusion sheet behind the Pushover logo, but technically wouldn't be original, and in person it doesn't wash out so much as it does on camera. But if you're watching this, that means that over on my longform channel, there is the complete restoration of this from all of these TikToks, all slapped together, so you can go watch this thing from beginning to end. Wait. You've gotta be kidding me. Now we just need to put these on the pushover. I was just looking at this image even closer and realized I'm missing the little arrow that points down at said control. There we go. I went ahead and sprayed a new layer of the matte clear coat. Had this been normal, shiny, glossy clear coat, I wouldn't have been able to just paint over it without any issues. But since it's a matte clear coat, it's not smooth or anything, so I was able to just paint over it without any issues. Then add another layer of clear coat. That looks absolutely fantastic. Obviously, this is before. This thing just looks so good now. That text definitely adds a lot. It makes the front of this thing look a whole lot less empty. Literal vines growing on this power cord.